Hello everyone, this is Junchan and we are back on stream doing some Haskell and specifically working with data structures that are called cache oblivious data structures. So we have basically dug up a project from Edward Metz that he was working on 7 or 8 years ago. Hasn't been updated since, and so that means that we had to do quite a bit of, let's call it, software archaeology, where we're trying to dig up some of these old repos and trying to make them compile. And obviously the world had changed a lot since 2013, and well, gladly we have some superpowers. We have Nix and the ability to actually go back to a Nix release from a couple of years ago that allows us to grab a GHC version that will work with the caveat that it doesn't necessarily work for everything. And so we actually have to modify our package bounds, and I had to actually download and update some packages in order to get it to where we are now, which is that it doesn't build everything quite yet. Specifically, Lens apparently has a problem building. So let's check out what we can do. So this is Lens 4.8, and I think a lot of these errors are because I'm using a, let's say, relatively new GHC version compared to 2013, and so there's a bunch of errors that come. And so the easiest way that I know of to actually solve this problem so far, and that I've been using here, is to just get the Lens package, check out a commit that corresponds to, let's say, around 4.8, and then fix the errors. So that's what we'll do right now. So let's go for it. We will take Lens and we will go to Ed's page for that, and yeah, right, the pasting button from the browser doesn't seem to quite work. And then we'll find a package version, hopefully with a tag that will work. So we want 4.8 and there's the 4.8. Great. So we'll check out the 4.8. Okay, and then we'll advertise this package to be available in our local package lists, and we will I'm using the wrong keyboard shortcut, need to get back used to this. And then we'll we'll take a look. Well, actually we're just cabal build and just see if we have the same error messages. We should, except apparently 4.8 is not what we wanted. Failed to beat Lens 4.8, and hold on, so let's go check out what is the version that is listed here. 4.8. So, and GHC, GHC version is off. Is that what's happening here? So how did this work before? Yeah, this seems to be a GHC version issue, but hold on, why? We have 7.10.3. Oh, because of file path. Okay. So does Lens have file path? It does, and file path 1301 is what we have, but we have 140 installed. Okay, I see. Okay, well, let's relax that bound and hope that works. Trying file path 130 UC. Not quite sure what's going on here. Okay, let's double check that if I do not add lens to the local packet list here, then we'll have the same error message we had before. Lib lens 4.8. It's also trying to build statistics. Right, starting at module number 75 from data vector generic lens, and that's where the error occurs. And yeah, lens 4.8. Is that one of these things that has been, maybe the tag has been mutated? So let's take a look at what occurs if we go to 4.8. And let's see, add missing module headers. It looks like it's from 2015. And yeah, it looks fairly contiguous. Apart from that March 7th thing. No, yeah, it's. Then what do we have here? Fusing and whatnot. It's trying to compile statistics here, but yeah, lens 4.8. So what's the deal? Okay, I don't know where I should sit to this. Okay, let's talk about library base. Tested with and oh, statistics has, well, it has warnings, but yeah, it seems to have built, so it is lens that is holding us. And yeah, I can't really tell why things look so different. If I add lens here, seems like, well, maybe I should try 4.7. How about that? The one just before. Yeah, that's fine. Let's try with that. And so it seems like maybe adjunctions. Could adjunctions be the issue? Because it starts by saying that adjunction is the problem. We have 4.4 installed, but target requires exactly 4.21. So yeah, that sounds like that's probably what's up. But you know what? Let's try something else actually. Let's go for the next version of lens. How about that? 4.9. And give it a build. Okay, so it's just structures that might not want it, so we have a lot of control over that. So let's allow it, and let's say 4.10. Okay, well, I found the build plan, so that's nice. And it's rebuilding vector, or because maybe vector depends on lenses. Is that what's happening? So maybe that was the thing that was preventing us from moving forward. Then I'm not sure. No, it doesn't. Okay, I'm not sure why a new build plan was selected, but at least it looks like it's building. Okay. So why did I create this playground here? You know what? I'm not exactly sure, but it's good to have. We can import. Oh, I wanted to import containers and do cabal REPL to play with data map. That's what happens. Yes. So let's see. It seems to build, and okay. So is it time to go back to the implementation and not vector, source, and we can close lens, and then check out maps. Yes. Yeah, we were looking at an API for short tree possibly, and then an API for, well, an implementation for short tree, and then maybe an API for interval-like queries, or range queries more specifically. And so I did have interval map open right there before. Well, the thing with interval maps is that it's a map with an interval as the keys, and the ability to know about containment and overlap. So that's nice and funky. I would kind of like to try this to implement a fast Clash Oblivious data structure for that, but I think we want to start with something simpler. And so maybe what we want to do is take a look at what Cache Oblivious, is there something as a Cache Oblivious tree? So B tree, yeah, it keeps going back to these B trees. I think I've done those searches before. And how about Cache Oblivious rose tree? Cache Oblivious B trees. Stencil computation, interesting. LSM. Maximum cache performance. Okay, let's try like so. Rose tree, Cache Oblivious. Info about trees data structure. What's that going to be about? I see. Just some link harvesting or click harvesting thing, I fear. Passing a list gives a rose tree. Yes. Is that in here? You see checks trees? No. It must have been one of these one of these cases where our search on Reddit, is not reliable, right? Because of these articles that are close to each other. But let's see what's up though, because I think Ed might be talking about interesting things we got to map here. Writing a decision on Haskell project using map.data.map, comment on the efficiency, a meaningful OR instance. That OR instance of some type prep from type perfection package support meaningful comparison. Designed to provide okay performance for a wider variety of type and operations. It's a decent data structure to start with. When you have figured out just what you need, you don't know what your data will look like. For high performance work, you're usually better off using something like int map, hash map, generalist tries, cache structures, etc. behavior of the old instance do matter for performance. Symptotic complexity of the operations named in the data map take the cost of a comparison to be O1. This means structural compares on long string or deep syntax trees can be considerably more expensive than the state's costs if you want to be efficient. When using those kind of deep structure as keys, some kind of trie structure works better. So let's refresh our mind with what a trie is. A digital tree or prefix tree. A type of search tree, a tree data structure. Okay, so do we have cache oblivious tries? Simple and cache oblivious tries. Is there a simple and cache oblivious data structure? Ternary search trees, string bit tree, cache oblivious ones even more complex, and do not achieve the IO bounds in the worst case. An idea similar to this one is driving digital access to comparison-based tree data structure and structures and algorithm. An idea for structure that might meet these bounds is the balanced binary search tree where each node is annotated with a pair of integers to indicate how much of the prefix of the keys does not need to be compared again with the search key. Oh. Interesting. So that feels like a tree of bounded balance with some additional annotation for prefix search. So clearly not an obvious thing, not something that seems to actually exist. Low depth. Let's see in Haskell what are is there a data.try? I suppose there might be. In the package, yes. Byte string try and word try. Efficient implementation of finite maps from string to values. Implementation is based on big endian partition trees like data.int map. First try on the elements of data byte string and then try on the big endian big representation of those elements. Austere interface while being detailed enough for most users. For an extended interface with many additional functions, see data try convenience. Okay. What's in there? Alright, some inserts and folding. And here empty and keys and whatnot. So partition trees I hear are really fast. Can we do a oh no, that was int map. That wasn't the convenience function. These are the convenience functions. From list, lookup with default, okay. Searching values, updating, and combining tries. Okay, and so data.int has two interfaces, and one is lazy, the other strict. And this is the lazy implementation, and it has this very limited API, just 4 things. But there's union and intersection based on big endian partition trees. Data structure performs especially well in binary applications like union and intersection. However, my benchmarks show that it is also much faster on insertions and deletions when compared to generic size balanced map implementation like data.map. So that's already an improvement over data.map. Let's take a look at that lazy. Yeah, here we have indexing, difference, null, size member, insertion, delete, adjust, update, alter, combine. I probably want to play with that. Because I wonder whether, you know, our original thought here was to take a look at whether the Zettelkasten tree structure could be implemented with this cache oblivious map, but it could be that actually a trie or a prefix tree is actually the better way. Maybe, I don't know. I need to familiarize myself with these structures to see to understand their shape more. So yeah, there's this, but there's also then the fact that one thing that could implement the range query is a kind of a well, you know what? I'm thinking about something as I say this. A show is not needed. If I have a map, if I have a, let's say, a J and a K, or that's an I and a J, so really yeah, I and J with ORed on IJ, and then a map oh, sorry, it's really K, yeah. K to K and a map K to V, then there is a range that could return a map KV, but that's the tricky bit. So maybe we want just like a list, or, you know, a vector. No, a vector. Oh, well, maybe a vector actually. Or what is basically the question, right? How do we make this fast? That would be some kind of range prime. And so is there, this returns lists and is subject to this fusion. So I mean, lists are a bit like a stream in Haskell, so maybe it is a okay interface. And here actually from list does take KV, right? We don't have a to list, at least for this structure, but we might have a to list for another one. Let's go check out. Yes. Oh, right, I think I started writing that. So but this takes foldable to list and it's for insert. So okay, so yeah, maybe I want to actually start playing with and I'm still being confused about my keyboard shortcuts. Maybe I want to start playing with two lists. Maybe that's the way. And then range might be a next one. Let's see where we are with compilation. Failed to build lens 4.9. Okay. It is with the version of streams. Okay, let's take a look, but I fear that's going to get us into a deadlock. Source data vector generic lens, and we have data vector fusion stream. Sorry about that. So let's take another look at map here, and here we use this guy. Okay, no, it might work as long as the API is not using the size, which I think this isn't. So, oh right, like so, and then 94. Well, actually, that might be sufficient. Yeah, I'm not 100% sure. But I'll take a little break and be right back. Okay, I am back, and well, seems like we have exactly the same error. So changing that stream implementation is not what we need to do. Let's see, or the import 88 as stream, and let's see what is supposed to be the type of stream. And here we're talking about data vector fusion stream monadic, which is from the vector package. So data vector fusion stream. I suppose there is stream, and that is importing or re-exporting stream monadic. Pretty sure. And the mstream ID. Right, so no, so actually, hold on. Seems like using stream is the right thing. So what's up with that? I thought it gave exactly the same error message. Are we using lens 4.9? Are we actually did we do the change in kebab project here? We did, and oh, we did, but did we check out lens 4.9? We did not. Okay. So did check out the 4.9, and let's do kebab 4.9. Okay, and then kebab build. Yeah, no, still, I actually did have that checked out then. Sorted of vector lens 88 stream should have. Yeah, but I disagree with that. Stream should not have kind. Oh, hold on. Stream should have kind star to star. No, the first argument of stream, yeah, stream itself has kind star to star to star. Well, okay, let's go back down into stream vector fusion stream again. And here we have stream VA and mstream MVA. I see. So stream indeed has two parameters. It's just that mstream has 3, and therefore mstream, like here, was like, oh well, should just remove. It should go from 2 to 1, but no, it goes from 3 to 2 arguments. Okay, so VA and VB maybe, huh? Yeah, I think so. I think, yeah. So let's try that. VB, VA, VB. Yes, indeed. And it compiles the whole of lens. It does. And it compiles structures, therefore, and it doesn't. But we are getting really close. Okay, data vector array. We're now actually in the main package and solving issues from here. So data vector fusion bundle. Okay, I think we're talking about data vector fusion. Oh, right. So you wanted bundles here. Is that really? So that's from the version of vector that comes next. Hold on one second. How much of these bundle dependencies do we really have in here? Because we have it in array, slow, and fusion. So now I'm starting to think that I made the wrong choice of a vector. You're going back to 0, 10 to solve other compilation problems, but now to get this map to compile, fusion stream monadic. Because we lose fusion stream monadic from the next version of not lens, but vector, right? So at 0, 10 we have stream, but at 0, 10, 9 we get this guy. Okay, well, let's try and not get the vector fork, just to understand whether we really made the right choice. And then structure cabal. We want probably something that's less than 0, 10, 10, I would say. Let's try that. Junctions, lens, vector, rejecting vector, 0, 12, 0 installed, trying 0, 10, 12, that's also not good. Maybe it's not in the package registry. Okay, so let's go to vector, and okay, we want, this is a working, oh, I should have created a new branch for this. So that's the working 0, 0, 10 working. And right, git checkout 0, 10, 9, 3 v, and cabal build. How about that? Why did I think I've tried this, but why didn't it work? It's a bounds issue. Oh, I need to re-add vector into the cabal project. And drink a bit. The deep sec bounds. Okay, I can go down to a slightly earlier version. I don't know whether that actually changes anything with the deep sec bounds. Yeah, again. This had 1.5 here, but I think that's one of my changes. I'm pretty sure. Yes, indeed. So I suppose we can make the same change. In fact, maybe we can cherry pick a whole lot of stuff from there. But let's start with. Oh, we I think are already on the place I want. I know we are on here. So check out 01093, and then let's make the cabal change to 0 to DeepSeek 1.5, and I think primitive 0.7, right? Yeah. And then see, it could be that we can just cherry pick that commit really, but we shall see. Yeah, because I think a lot of that stuff is in fact from primitive, and so it does build, and yeah, same errors. Okay, so let's see. Can I get log 0 working? Okay, let's get check out 0 working. Oh, I'm not in vector. Okay, got it. And 0 working. Here we go, and we shall get cherry pick that. Yes. So we'll restore vector.cabal and we'll cherry pick. And some conflicts, but not too bad. Yeah, that is I think good, and a few more conflicts. Data vector and box base. I suppose it's not giving me the vector package here. Yeah, that's all good. Will it be in the repo? No, yeah, those are the workspace. All good, all good. We can see them here. Data vector and box base in a vector, data vector and boxed base. Right. So here, this stuff is completely this is in an endif, and this is not. Oh, and there's this as well. Yeah, I think I want. I think I'm going to try to go with only the incoming change. Oh, what? Yeah, and then here also the incoming change. Let's see. Cherry pick continue. I think git add and git add vector and git cherry pick continue. Okay, I see. Exit, save, sure. And we cherry picked, and now we are going to try and build. Probably should have created a new branch there, but and if without if else, yeah. So there's a missing and if, I think here, right? That's an endif without if. This endif I think maybe is not needed. First endif, and then 70 else is not terminated. Okay, yeah, so we do need another endif here. Oh really? Oh yeah, look, there's some weirdness up there. Yeah, I think we want just this guy. And, all right. Seems to be building. It'll take a bit. So let's go back to tries. If you want to get back to tries, then well, we want to try try, I think, and that's in, well, there's several, but there's byte string.try and word.try. There's such a thing in Agda as well. So what's the difference there? The driver words. Experimental finite driver words. 2015. Okay, that seems fairly unmaintained. How about this? 025 2019. It's better, right? Okay, so let's play a bit with that. And go to our playground, add byte string try. I think this is actually our playground right there. It is, and so we'll cabal build. And byte string try won't work with our current Haskell. Less than 414. And we're using 414, and it needs to be less than 414. So let's go take a look at whether people have created updated forks. Maybe let's look at pull requests. Bump up a base, support HC1010. There we go. We have one right there. And merging push, bump. Nobody's merging and pushing. So we need to use this. And git clone. And check out the EHC10 update. Okay, and then well, cabal REPL. Good, the cabal build, cabal REPL should work, except we need to do a cabal project file. Cabal.project. And say packages dot and byte string try. That's enough, right? Oh, binary is the issue, looks like now. And bystring try wants binary less than 0.8, and that's the one we have installed here. Well, let's adjust that. I'm sure it doesn't really need binary less than 0.87. We can probably say 0.88, so 0.89 here. And let's go check on our compilation here. Still compiling, that's good. And this seems to also be compiling. And we're in a REPL. And so we can import that at our try, I believe. Our try. Yes, we can. And then we can browse, I think, data.try. That's right. And so just delete elements from list, insert. So we probably want to again start from a singleton try or an empty try. How about, yeah, we could start with a singleton try. So that takes a byte string and an A. Okay, so A equals singleton, taking a byte string. So I would need overloaded lists, I suppose. But let's try it like that. And then an A would be just an integer. Does that work? Yeah, you're not going to be able to make a bash string out of that chart. There's a way to add yes, minus dash, okay, set dash x overloaded strings. Does this work with byte string? It does. And so now we can insert, and well, we can ask for the type of insert and say, well, b equals 234 and 234 added to A. Oh, right, insert. And can we show B? Yes, we can. It's the list, and that's it. So in theory, this would be efficient for prefix search. So let's look at data.try again and see what's a prefix search. Then does it match? Try A and a byte string. Yeah, I think so. So let's see if we do C equals insert 23456 of 23456 of B. Then if we match C and 233, actually, how about that? Nothing. And 234, 234 finds 1. 23456 finds 1 only as well. So match, oh, then matches maybe. But with 234. No, still only 1. And 23, only 1 as well. So don't see a prefix here. So let's look at the docs again, but let's check where our compile is at. And oh, data vector generic length to too many type arguments right there. What? We just changed this, but then we changed the vector type. Okay, so that's fine. We can do that. Generic length. So we just need to revert this. So that means actually that we can just use maybe the package version, and the package version we want would be 4.9. And so let's remove length from here and then just rebuild. Check that it will take give out 4.9, length 4.9. It does. Oh, 4.9.1, that should be fine. And let's look again at byte string try and the interface for it and search. No prefix. Lookup by rooted at the prefix. Okay, let's try and do lookup by. Type of lookup by is just lookup then, please. Yeah, lookup 234 C. Ambiguous. Try that lookup, and it says that it finds the key, but okay, submap looks like what we want, but yeah, it is. There we go, we get the 2 ones. So that's a proper prefix selection. And given a query, find the longest prefix with an associated value in the tree, turning that prefix's value and the remaining string. That's a little bit unclear. The longest prefix. So it seems like really the use of prefixes is basically submap. It doesn't say what the complexity of submap is. I don't know that I want to get lost in the papers. All right, how are we doing here? Okay, source data vector array. Could not find data vector fusion bundle. Member of the hidden package 011. So hold on. That's a bit strange. Okay, let's look at array. Fusion bundle. Okay, let's look at vector. Fusion. I thought I was trying to go a step forward in time to get the bundles. But 01093 doesn't have the bundles? It doesn't. Okay, so that defeats the purpose. Bundle 0109, 0193. Oh, you're kidding me. Zero ten 01090 just had the bundles that showed up, and then okay, fine. Yeah, git checkout E010. Well, let's tag first. I'm not even sure whether it's there. 0190, it is there. Git checkout E01090. Yes. Yeah, why not? Okay, and then I think I'll cherry pick again, basically. Cherry pick. Yes. And then you have a few conflicts. So cabal, and we accept the incoming change. We are good. And vector.hs. Apparently, Fusion bundle versus Fusion stream. Ah, right. Okay, I see. So I think we'll need to copy this. We need to basically accept both, which means really getting rid of that one, I think. Yeah. And then box base has the same problem, and yeah, so we'll just well, we'll just have to do it again because we can't cherry pick in the cherry pick. So we'll accept that, and we'll accept that, and then I think we'll have the same. Well, we'll make sure that we add all things, and then we cherry pick continue, and then we cabal build. How strange. Let's see if the change log actually. Well, there's no change log. Okay. Don't know what the hell happened there. Probably an error in pushing the. Yeah, we do have the same error, and so we, I think, remove that one and then add that one. Okay, so now we have a bundle. And we can go back to playing with our try. So try really only is it correct then that the try really is the submap then? Let's say it map lazy, maps from integer keys to values. Strict keys, they need values, you need very strict map strict. Share between lazy and strict. Begin trees, students properties, query, size member, not member. Combining map. LMs. A submap off. And then max. Yeah, although those are either min or max, there's no real min max. And then the debugging. Okay. Do we have a show tree for let's say C? We don't. That's fine. And where is our compilation? It's happening. And let's look at the implementation. In fact, we have the implementation right here. Version functions. Lookup. Okay, where are the types? Internal. Yes. Try without the constructor. Okay. Well, there's in the internal module there's a bunch of docs. So let's go check it out. Okay, we need to go here. Hold on. I thought there was this doc. Where did it go? Well, that's unfortunate. It doesn't display here. Yeah. Well, I'll have to read it from here, which is fine. Okay. Got to be lens. Could not find data vector fusion stream. That's right, because now it's monadic. And that's fine, I think. Let's hope we're not. I mean, I'm taking a version of vector, which I think, yeah, I mean, I think it's correct, but data vector generic lens, and could not find the module. That's right, because it's now monadic, I think, monadic stream. Or bundle ones. Which ones are the ones needed? Not sure. Data vector fusion stream in hybrid vectors. Yeah. I've been moving my goalpost here in a pretty nasty way. That might backfire. I might end up having to go back in time. So hybrid vector is not built, but also lens is not built. So data vector fusion stream lens.hs data vector generic lens. Did I not save that? I look like I did. Oh right, but it's just that I was not importing lens anymore, I think, in the global project file. Is that right? It is right. Okay, yes, so let's look at the hybrid vectors and specifically hybrid internals. Aha, right. So which one are you having trouble with then? Data vector fusion stream. Because we're not at 0.11, but yet we use fusion stream. That's right, that's right. So that's all correct. And so in fact, we can do this. Okay, cool. Right, and we were looking at the docs in here. In our alias representation, we use a directed discrete graph to represent our finite state machine. Oh. To organize the set of outgoing arcs from a given node, we have arc set, a big-endian partition tree like data int map. In order to simplify things, we then go through a series of derivation. Accept an arc set, reject a branch. An arc has a byte string and a node. An arc set has known one key element or branch with a prefix and some mask, and the trie is either empty or has a start of byte string node A, which is maybe an empty string. If we maintain the invariance of how node recurs, then we can't simply have start node A, because we may have a shared prefix where the prefix itself is not accepted. I have no idea what that means. Squash arc into one, pure good. Most likely good. Squash node together. Squash empty node. Okay, so really a trie is either empty, arc, or branch. Serialization does not unveil the innards of our abstract type, does not emit truly proper Haskell code though. Ah, right, because show instance needs to be readable. Yeah, I think that's a loosely held thing. And yeah, read. Show try. Oh, there is a show try thing. Okay, let's try the show try thing. From data.try.internal. Interesting. Okay, show me A. And let's put stir line this. There we go. So A has 1, 2, 3, 1, 2, 3. B has 1, 2, 3, and 2, 3, 4, with a node at the top that says 48, 2. Is that one of these arcs? Or is that a branch? I don't know. And then what's C? Ah, right. C, that seems like it makes a lot of sense to me. So here we're approaching something that starts to look like what I want for the Zettelkasten structure, actually. Because in fact, we could really use the Zettelkasten, like the numbering system, let's say the paper-based system here, and that would actually preserve exactly that structure. So if we did from list L, sure, why not? From list L with a list of, well, a list is going to be a list of pairs of, and we take the example like 0. And let's say we don't put anything in it, we say units. Ah, right. So I think we then, oh no, we do need to pair it. Yeah. Tuple it. Oh boy, terrible with the keyboard today. Tuple it. Do 1. Do 2. Do 3. And nil. Did I mean from list from data.try? I'm happy with from list from data.try. But we probably want an application. There we go. And so now we have a try, and if we put stir line of show try of this, well, we need the data dot try internal, and then the put with the correct. There we go. So now we have 0, 1, 2, 3, and these things are what they call the arcs. But what I think matters here is that now I can later add 1A, and it will go exactly in the right spot, which is after the 1A. So that really does sound like exactly what I want, because if I would do then 1b, that goes next to b, which is what we want. So it's a slightly transposed thing, but I think the spirit is exactly what we want. And so if we do 1a1, then yeah, we branch on of a and we add a 1, and then if we add 1a2, we branch out of 1 and the same a. So yeah, that looks a lot like exactly what I want. So I want to try. So can I do a fast oblivious try? A cache oblivious try. It sounds like that's going to be really tough if I start from here, because here is these weird arcs. But it's also using data.intmap as the sort of as an internal store of sorts. But not explicitly here, nor here. Okay, so hold on, does it really use intmap at all? Data.intmap. These are all comments. Code is duplicated from data.intmap. Like data.intmap. Okay, let's see if we can look at the code of data.intmap and recognize what we see here. Meaning it is the implementation of the do we want the lazy one? Well, let's okay, base is probably what we want. That's linkable. Great. Base and right. Okay, so it is similar in that branch. It has been a prefix, a mask, and the 2 tries. But the tip is a different concept. There's no real tip. And the prefix has which type? Is it in bitwiddle? Yeah, expose prefix. Right, it's different. It's a key element instead of an int, which I suppose is what gives it its. Okay, so let's look at other Patricia trees in Haskell, really, because maybe there is a byte string. I mean, I haven't yet understood. Well, it would be useful if this arc thing was in fact a kind of an optimization, and that there was such a thing as a maybe naive implementation of a try, a byte string try from a Patricia tree directly. What's a list try? Tries in Patricia trees. Implementation of finite sets and maps for list keys using tries. Oh. Okay, if this is what I imagine, then that might be even better, because then it could be that the prefixes. I don't know if it's better. Actually, I kind of like the byte string matching. It feels like that gives a lot of flexibility. It does, but then like I need to think about the API for this, because the refactoring, maybe I should take notes. So that really doesn't make sense. Custom tries. So we can have something like zero, 1, 2, 3, with 1 having A and B, and A having 1 and 2, right? That's what we have now. Yeah, I think I already know my response, because if this is instead a list, and I still don't know whether that's actually what those list keys are, but it sounds like that's probably the case, then this is more refactorable, because I can be like, well, this is now A prime. Whereas here I'm going to have trouble, because it's going to use the byte string splitting character by character. And so in fact, it's going to have like a prime here, and it's going to be a mess. It doesn't mean what we want. So yeah, so byte string try is like so, and so hopefully list try is like so. And let's check what that's the case. Clearly we don't want that. List try base map, list try map, list try set. I think list try map is the right thing, isn't it? A map from keys of type list of k to values of type v. Yeah, that is totally what we want. I like that a lot. And what does this make me think of? Well, let's play with it. I forget what this makes me think of. Like using a list here, list of keys. Oh, well, the interval map. But the interval map. Maybe that's a more powerful. Because if we have containing as well, then maybe that's better. So better for refactoring. We can have an A prime here, and 2 and 3 and B. And with an interval map, if we go here, we have an interval. So now we have what? We have something like 0, 1, 1, 2, 2, 3, 3, 4, and then here we have A, B, B, C, and 1, 2, and 2, 3. So this gives us the ability to say A to C, and then get all of this. Whereas here, we can't do that. In fact, I think in the list try, this is more like what it is, right? I think we're saying 1 a prime 1, and so is it this refactorable? Huh, might not be. It depends on the usage, so we need to try it. Try. How do we do that? We go into the Cabal file of our structure playground, and we import list try, right? And the Cabal REPL. Try package. Let's try. Let's tries. Empty singleton and conversion. Yeah, let's do the conversion. A map from a list of key value pair. If a key occurs more than once, then the value from the last pair is the one which ends up in the map. The map. Okay, yeah, that's fine. So I think import data.listtry.map actually. Data.listmap listtry.map. And do we have a show instance? Probably we do. Visualization, show try. So we kind of want to do that, don't we? We do, except yeah, the from list that we want is different than this type of from list. Yeah, it takes a list, so that's where we have trouble here, I think. And so if we say this instead, whoopsie, okay, this, and here we have to say this. Oh well. Oh, hold on. That's not Haskell. Or is it? No, it is, right? Oh no, I stopped it. Import and let's try .map. And get it again. Should try. Let's start with something simpler. Just make sure we're not doing something weird. Yeah, clearly we are doing something weird. So string to string with char. Actual type show s. Sorry about that. Show s. I see. Preparing the output string. Blah and blah. The use of show try. You're not happy with it? You're not happy with unit? It looks like you're not happy with unit. Okay. Right. No, that's not the case. Okay. Oh, what? Oh, hold on. That is try map. Oh, so it's not, doesn't actually take a list. Okay, there's tons of weirdness going on here. Oh, flexible contexts. Z minus X flexible contexts. And still a problem. So yeah, the from list instances are a bit strange. ONM increase a map from a list of key value pairs. QQ more than once, the value from the last pair. Yeah, we saw that. I see, it's the const that becomes the replacement for duplicate keys. Interesting. Yeah, that's a good API actually. I like that. But in what way is it a list of keys that becomes the? Because here we do take a list of keys, but here. Oh, here you're just taking this as a list of chars. And so now it's a list of lists. Is that part of the trouble? It's not, because you can't even manage this. Is it about the overloaded strings? Map string int. Oh, that's a constraint. Okay, maybe we just say this. Oh boy. Is a list of lists of chars and ints. And I close the parentheses. But you still can't find the type. That is really strange. And where are we with our compilation? We have trouble with the lenses again, but hopefully in the right direction. I kind of lost context already. Length, vector generic length, monad extreme, and perhaps we meant just fusion stream. Well, that's indeed how it was before, but I could not find that. Data vector fusion stream. It is a member of the alien package. It is the right vector, I think. I think we need to clean this with the problem. It sucks. So that's unfortunate that this try thing seems to be not working. That's the constraint that we want. And where is map? That's a strange thing. Where would it be map KV? Using map to map keys to map keys of type K to subtries. I see. So that's a real special thing that I had not understood was needed. Okay, but that explains the type of map problems and whatnot. But what we want is type of maps. And let's see. We probably want to check out the repo. That's the repo. And there are some tests. Yes, there are. Okay, that's all template Haskell. From list try type. What's try type? Arbitrary. What is this try type thing? Base map. Are you saying that you have a map in your map? Maybe we want to look at this. Historical record. So, I recommend using more specialized and optimized solution as byte-string tries when possible. I see. But I think elsewhere we saw there were conversion to byte strings, like fast conversion from vectors to byte strings, I think, right? And back and forth. I see. So, but yeah, let's capture that. Unfortunately, this tries not optimized. Recommends byte string try. So that might be interval map. And instead of making the space somewhat pointed with like or discrete, it makes the space continuous such that we can actually subdivide as much as we want. And well, subdividing as much as we want is a little bit already what this whole zeta custom thing tries to create. So it could be that in fact the interval map native way of doing what I was just writing above is in fact something like 1, 2, 3, 3, 4 is to say, well, actually we have 1.5 2, and then further say what we have actually 1 point, we have 1.25 and 1.25, 1.5. It seems like that would be the interval map native way of doing that. And there is an advantage to that. If we think of this as a continuous space, but is it a continuous space or is it more a kind of discrete space where in fact we want these keys to have meaning? If we see the key space as only used for ordering, then intervals make sense. But the better view might be to see keys as symbolic and discrete symbolic anchors. But what about blank anchors? Like, I'm thinking these are sort of blank anchors. Then we don't necessarily want to have to pick up a key. We want want to preserve the structure, which this does. Although it's unclear how easy it is to, well, how it is to produce these, and then how easy it is to. Yeah, no, I think it's probably fine. It's a bit more work, but I think we should be able to basically do pretty much all of the same operations, like go back to the parent and match for exact, do an exact match and whatnot. But having to come up with keys is a problem. So we want some flexibility with regards to that. So it's a bit almost like we would do auto-generated keys, and then we'll have another index from auto-generated key, not to value but to a title, a symbol, an identifier. So we could have auto-generated IDs and an index to human readable identifier in addition to the map from auto, well, let's call them keys here, keys from auto keys to cards, right, which is what we ultimately want to store here. Where are we with our compilation? And we fail with not finding data vector fusion stream in data. Okay, let's go check out what that is. It's here, and data vector fusion stream, not a member of 0, 10, 12, 3. So could it be that the vector package we added in data vector fusion stream actually lacks stream? That's the case. It lacks stream. So I suppose we want to be just calling them monadic and hoping that it works. So let's try that. It's the other way around, isn't it? No, stream. Yeah, it is. Monadic. Yeah, we could really rename that one stream, but that's not. Okay. So that's. I mean, that's one iteration, but what I dislike about this is that all of a sudden now we have two data structures. So making it fast is not as clear. Also, I need to think a bit more about search. Because it could be that actually we do choose symbolic IDs, and then instead of being auto-generated keys, they're just not yet human readable identifiers, in such a way that if we use them in byte strings, for instance, then we could have something like okay, I need to have a running example for this, I think. Well, let's say this right there below. Zettel Kasten map to an initial paragraph, like some kind of Zettel custom dot one thing, so like a blank. Which has the started looking blah blah blah, and then we have a Zettel custom .1.2 that's import, and maybe it's special here because of its because we parse it in a specific way, which is import from this da da da, and then we have another ID. This doesn't need to be 2, it can be 1, and then this would be neuron, like pretty much da da da, and then this would be Zettel custom, and I suppose we could have a paragraph mark of sorts. Yeah, that might be better. And we could say, yeah, this is a paragraph mark. And so this would be the second paragraph. So let's spend blah, blah, blah. Okay, let's try and look at this computation error. The vector generic lengths. In the lengths library. And apparently, stream VB, bundle VB. Yeah. So it's not going to work to get back to this version. It's on line 89 that matters. IDVB, bundle of IDVB, actual type. Yeah, and that's not going to work. This is tough. Which version of lens are we trying here? Trying 4.9. So let's go at something more modern, like 4.19, and see specifically how data vector generic lens is implemented. If it is implemented in terms of bundles, it is. So in which case, maybe it's just a matter of either going further forward in the lens library. So instead of, what did we say, 4.9, we can see if in the neighborhood like 4.12. Let's see whether the vector generic length had bundles here, and no, here it has streams. So it took it a while to update to bundles. So that's going to be trouble. 4.13 had bundles. Okay, so I suppose in theory we could just try and just replace all of this to vector of forced blah 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 ordinals vector ix. It theoretically it could work. Let's try it. And eat a little bit of banana. We really want bundles, but structure doesn't use bundles, right? That's one of our main problems. I think I'm leading myself astray here. I think this is not going to work. I think trying to update everything to bundles is probably going to be too hard. Although now I do have a model. I have the diff between length 413 and length 412. That's pretty neat. So let me actually open that up as a GitHub diff. That's going to give me a sense of, in fact, really how difficult it is to move from one API to the other. Because I'd rather use the later API, but I was a little bit worried about how much trouble it was going to be. So let's see. We need to go to tags. And go to 413 and compare it to 412.3. And look at bundles specifically. Bundle vector. I see. Yeah, it's still loading. The vector. Okay, let's do bundle again. Control lens con. Vector there is, but control S wrapped. It's not really what we want, right? data vector primitive prim. And I still don't know what's creating this error. Control S cons. This is new. I think that's a rendering artifact actually. Yeah. Okay, so am I missing something? Data vector generic lens based on bundles, version 4.13 and version 4.12.3. Data vector generic lens based on bundles. Okay, I see. So that's not the thing I was looking for. It must be with a minor version then. So 14.12.2. Bundles and 14.12.1. Bundles. So it's 14.12.1 and 14.12, right? Yes. Okay. So 14.12.1 1 and 14.12. On 14.12 and vector generic lens and fusion stream. Right, so I think I wanted it in the other direction probably. Yeah. Vector 0.12. So let's see, how big is it? That's a combination of things. Then, okay, there needs to be this other as stream that just takes bundle VA without much more modification appearance. And that's it. Holy moly, it is pretty simple in fact. So maybe I shouldn't be so worried and just embrace a later vector version. And that sort of makes me want to pick up vector 0.11 and then to upgrade structures. I think that would be the most natural thing. And so if I do that, well, let's do it by also saying that we actually only getting the vector, or only getting the local package now. And let's see how far we go with that. It's kind of resetting again, but at least it seems like we don't have any issue with the execution. But lens 491 we know will fail, so we'll want 412.1. So let's go ahead of that and do 4.13. And we know that hybrid vectors are not updated, I'm pretty sure. So we're going to need to upgrade those if they use those, and they do. Oh no, but they will be upgraded as long as we have the current the proper vector version. So it should be fine actually, as long as we get the latest version of hybrid vectors. Okay, so maybe it was the solution all along. We shall see. I mean, it will mean anyway that I'll need to change these to bundles, basically. Change anything, any reference to streams here to bundle. But yeah, I think it seems like it's not so hard, right? Like we saw here that it was really nothing apart from changing the name and adding the key of the what is that, the vector dimension, right? So okay, but you know what, that's where I'll stop today, because I'd like to rest a bit, and it was a pretty intense week. And so I think well, I might change my structure and continue with this next week, because contrary to the other projects, we haven't spent a lot of time doing this, and so there's quite an investment in just getting started. And I like to, designing the proper data structure that I want to build off of for a lot of these different projects. That's something that I feel is going to be beneficial to the other tracks that we're doing the other days. So I mean, if it's not completely obvious why these things would connect, well, it's because I want these things to be connected by a similar. I want my knowledge management structure to be a CRDT, so that goes into a chronofold, and I might want to compose them with chronofolds in such a way that my my value type here in my map can be a chronofold or a reference to a chronofold somehow. And then I'll probably also want this data structure to be both queryable and updatable or appendable from a Dunai Rhine setup, so that I can use it a little bit as a way to say, well, both as a file system and as just as an indexing tool for instance, a project. And I'll be able to say, well, this is a project, and it has then all of this sub data structure in them. And well, it connects a little bit to then thinking about GPU programming, because I might want some of these structure to then be also marshaled to GPU memory, especially if we start doing things like graph algorithm or graph layout algorithms into the GPU. So yeah, and the overarching thing that I haven't talked about yet much is that I want knowledge to be the driving spine, so to speak, of all like smaller project that I'm doing. And I want this to be like a unifying concept for everything else. So a way to anchor things. That's better than a file system with just folders and files. That's better than this log with these dates, but that are not really computable. That's better than the notion of, like even up down to the level of like tabs, and to the level of the specifics of how, for instance, there are also hierarchical layout to an NLE and a video editor, and to keep these structures unified, so that in some sense, if you think of it as a file system, and we might also want to build a file system interface, like a Fuse interface, for instance, to it, so that we can drill down inside folders. Then in some folders, you might discover, well, that's a video project, and I'll drill down into this track, and I see the clips and so on. So all of this is a quite a grand unifying vision, and so we shall see whether I get to the point where it's actually possible. But check this out, everything compiled except for structures. So that's a great point to start again. Next time I will resist the temptation to actually go and fix it. Yeah, that's pretty good. All right, thanks a lot for watching, and I will see you very soon. Bye bye.